X-rays. X-rays are a type of radiation that is in the electromagnetic spectrum. They have a higher frequency than visible light and can penetrate most solid materials, including the human body. The electromagnetic waves of X-rays have extremely short wavelengths and high frequencies, with wavelengths ranging from about 10 to the power of -8 to 10 to the power of -12 meters, and corresponding frequencies from about 10 to the power of 16 to 10 to the power of 20 Hz. German physicist Wilhelm Conrad Röntgen first discovered X-rays in 1895 while studying the effects of electron beams, also known as cathode rays, in electrical discharges in low-pressure gases. X-rays are produced in a vacuum tube where electrons are accelerated by a heated cathode which contain an extremely high voltage and directed into the anode, a target material, which is a conductor, usually tungsten. These incoming electrons release X-rays as they are absorbed and reflected to the target material. With the voltages that are common for the medical X-ray machines, there are two types of electron to X-ray conversions: Bremsstrahlung and characteristic radiation. Bremsstrahlung occurs when the electron slows down as it passes close to the center of the tungsten atom. The loss of energy is then converted to an X-ray photon, and depending on the distance to the nucleus of the atom, the X-ray photon will then have different amounts of energy, resulting in an X-ray spectrum graph that is spread around 10 to 120 keV. X-rays can be used for a wide variety of industrial research and medical applications. X-rays are mostly used in diagnostic medical procedures, and there are more than 12 million Medicare claims for X-ray examinations each year in Australia, according to the Health Insurance Commission. X-rays are also used in medicine to treat cancer, and the process for it is called radiotherapy. The human body's bone's high calcium content allows for greater radiation absorption. X-rays provide a clear depiction of the skeletal structures that are present in the body. The softer tissue enables X-rays to pass through and is visible as deeper tones, whereas the bones absorb X-rays and appear as lighter hues. A body part, such as a fractured arm or leg, can be placed in front of an X-ray detector and exposed to a brief burst of X-rays, which can show the fracture or injury of that body part. The procedure lasts about 1/50th of a second. X-rays can also be used to diagnose illnesses such as lung disease by comparing soft connective tissue. However, they are not very useful for studying homogeneous tissues like the brain or muscles. There are many benefits of X-rays in the medical field. However, these applications also come with some risks and limitations that may impact certain factors. X-ray machines are widely used in medical diagnosis to produce a visual image of the radiographed body part of the human body. The image is the product of the radiation's differential absorption, which is dependent on the thickness, density, and structure, as well as the quantities of the numerous chemical elements of the specific body part. This can greatly assist in medical and surgical treatment planning and guide medical professionals as they can insert catheters, stents, or other devices inside the body, treat tumors, as well as remove blood clots or other blockages. Even though there are many benefits of X-rays in medicine, there are some drawbacks that are included too. One of the purposes of X-rays are to enable the contrast of the different body parts in order to differentiate the position of the bones in the body. However, despite the efforts to improve contrast, one of the fundamental limitations of this process is the frequently low contrast separation between organs or portions of an organ. Another limitation of this process is because of the extremely high frequencies of the waves, and excess radiation of this wave can cause severe damage to the body, such as carrying a risk of cancer, vomiting, bleeding, fainting, hair loss, and the loss of skin and hair. However, X-rays provide such a low dose of radiation that they are not believed to cause any immediate health problems. This leads us to the end of this presentation about X-rays, its history, the physics behind it, its applications in medicine, and its applications and limitations. You should now have a much more sophisticated understanding of this topic. Until next time, goodbye.